Hi all, welcome to week 3's post-tutorial recap after a 1-hour class. In this video, I'll be focusing on the calculations we have just learned. Right, so I have about 3 questions over here, so let's get started. So how is the second line of bracket series produced? So I told you that we have to remember what is the end final for each series. So for bracket series, end final is going to be n equals to 4. Alright, so the first line should be right above it. Okay, the transition of electron should be from the level right above it, which is n5 to n4. Therefore, the second line should go a bit higher, which is falling from n6 to n4. So how do we say that in word? I'm very sure that you all have mastered this, but saying it in line. So the second line in bracket series is produced when an electron makes a transition from the 6th energy level to the 4th energy level. So make sure you are using words like 6th energy level to the 4th energy level instead of just saying 6 to 4. Okay, this is a better answer. Right, next, let's look at the next question, which is first line of the Balmer series has a wavelength of 656 nanometers. Calculates its frequency. So this actually just requires you to use the SPM formulas you have learned, whereby speed, velocity, frequency. What am I saying? Frequency, okay, equals to speed of light over lambda. Now what I want you to be careful here is that nanometers must be converted into meters. So please take note of the conversion because the speed of light is always given in meter per second. So we cannot divide it by a nanometer, we have to divide it by a meter. So make sure to multiply it with 10 to the power of negative 9, and your final answer you can write it in the unit per second or hertz because it's frequency. Alright, so let's go to the next question. When an electron makes a transition from higher energy level to a lower energy level, a photon with frequency 6.6 times 10 to the power of 15 is emitted. Calculate the wavelength of the photon. So again, we are using the same equation as before, whereby frequency equals to speed of light over wavelength over lambda. So rearrange the equation and substitute in the corresponding values. You will get a final answer which can be converted into nanometer. In this question, they did not require you to convert it in nanometer, but usually the question will accompany by saying, please produce the answer in nanometers. So please take note how to convert it into nanometers. All right. So what did I do here? So it's basically 4.5 times 10 to the power of negative 8 multiplied by 10 to the power of 9 to get a unit of nanometer from meter. Okay. So next question is that what is the energy emitted by 1 mole of electrons for the above transition? So first of all, we have to calculate the energy emitted by 1 electron, which is, they have used the delta E equals to Planck's constant multiplied by the frequency formula, whereby you have energy in joules. Then to convert it into number of mole, to convert it for 1 mole of electrons, you just have to multiply it by Avogadro's number. Answer is usually in joule per mole. Kindly convert it into kilojoule per mole, and better to be in standard form as well. Right, so let's look at the third question. So here we have the Lyman series. Calculate the ionization energy. Yes, this was the last thing we did before we ended this week. Calculation of ionization energy of hydrogen atom in kilojoule per mole. So what did we discuss about ionization in our class? That it's about removing the electron from the atom to a very, 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 very high energy level, which is n equals to infinity. All right, and where does the electron start? Since this is hydrogen atom, the electron is in energy level 1. Okay, so substitute in the values of energy level in delta E equals to Rydberg constant multiplied by 1 over n initial squared minus 1 over n final squared. Okay, make sure to insert the correct Rydberg constant value, and then since it is in kilojoule per mole, therefore you must automatically understand that you have to multiply it with Avogadro number, and the final answer should be this. Okay, I remember we did a calculation in class which gave us a 1312 kilojoule per mole answer, right? So this is almost similar to that. That means your answer is correct. Alright, so that's all for this video. Thank you.